Not too long ago, I made a video about this thing, and boy did it stir up a response. One would think I opened the lament configuration and let the math cenobites out. Just look at all these comments. Now, if you haven't seen that video, I do recommend you check it out first. In this one, however, I want to address some of the issues and hopefully provide some fixes. But first, let's explain what the idea behind this monstrosity actually is. The concept is to generate an expression that contains no visible constants. It uses only one variable denoted by the letter n, and we are asked to solve for the limit as n approaches infinity. The idea then is to try and generate an actual number like so. Yet at the same time, we also want this expression to look rich and developed, like some actual real crazy scientist math. So as an example, making one which results in 4 could easily be made this way. But let's face it, this is boring. And you should write it this way. But of course, we want to avoid using actual numbers. Now, if we create something like this, it looks much better. Kind of scary, like you actually have to do some math to figure it out. But it isn't too hard to create. The evil equation, on the other hand, is supposed to result in the infamous 666. And while I came up with this thing, there seems to be some problems with it. Let's start with the one I found the most intriguing. This thing. Now, I will try my best to clarify what I think is going on. From what I understand is that the nth root of n as n approaches infinity gets close to 1 but is always greater than 1 by a tiny infinitesimal amount. At least this is what I think some of the commenters were pointing out, and I completely agree with that. However, we are after all dealing with a limit. Now compare this to something like n over n. There it doesn't matter how big the n is. It only matters that n is equal to n. There is no question that the solution to this limit is 1. We can even graph it. This thing on the other hand, when we graph it, we get something like this. And we can try to make n as big as we want, but the two lines never meet. Until maybe when we actually do reach infinity, whatever that could be. So I totally understand the temptation to view this limit as being always bigger than 1. I just don't think limits work this way. Again, I could be wrong. The whole thing kind of reminds me of the repeating 9 after the decimal debate. However, for the sake of brevity, let's jump to the next portion of this intriguing issue. The real question is how to deal with a summation with fractional limits. Now, the argument was that because this ends up being infinitesimally greater than 1, n starts at the second term. So what do we do if the bottom index is something like this? Well, the real answer is that we don't do this. Both the top and bottom limits need to be integers. Fractions don't work. Maybe we can make the index into the limit and try something like this. You know what? I don't even know. Let's just go directly to fixing this thing. Some people suggested to simply use a floor function for this thing, but to be honest, I want to get rid of those floors altogether. I decided that I have to make the whole thing work so anyone can do it on Wolfram. Let's start by setting up our basic limit. N goes to infinity. We will have two terms that multiply. The exponent over here originally was negative n over n, but I decided to replace it with this thing. So now we can plug our summation. This time I'm simply using n over n as the index, so there won't be any confusion. I decided to just replace those two. Now when it comes to the expression inside the sum, it is very important to put a bracket on the n, not the m, so that Wolfram alpha won't clog up on you. And then just n plus n for the first multiple. For the upper limit, I'm dispensing with the floor of e. When we test this whole thing, we can see that it comes out to 2/3, which is exactly what I want, and I got rid of the floor and the index issues. Now, for the second part of our crazy function, this is actually 10 to the power of 3. To make this more scary, we'll switch it to 1/3 root. Inside, I decided to keep the original ceiling functions, because these don't seem to be causing problems. I like the original pi, and of course the negative 1/2 factorial. Someone suggested I should use gamma, and yeah, that could work, but I just like the simplicity of the factorial. Now for this fraction here, we just have to make the thing look like some ridiculous expression made entirely out of n's. And here we go, our improved and modified monstrosity. Finally, we do end up using the floor function, but on the outside of the entire thing. And there we go. You can plug this into Wolfram Alpha and it will actually spit out the 666. Just make sure you follow the steps I gave you in this video. Now, if you do want to avoid that final floor function on the outside, you could also do this. But I just think this monster looks better this way. I also should say that I'm quite aware of the distinction between equation and a limit. I just like the phrase evil equation. Has a kind of a ring to it. If you guys think
solving for the evil limit
sounds better, let me know in the comments. I hope you all enjoyed this video. I'm super glad you guys are watching and getting involved. Keep it coming, and I wish all of you a great day.